Earthquakes are created. The Earth is made of 4 layers: the crust, mantle, outer core, and inner core. On the crust, the Earth's first layer, there are 7 tectonic plates, and these can cause earthquakes. Earthquakes occur when 2 tectonic plates collide with each other and making sliding movements apart or underneath each other. This releases energy, causing tectonic waves to surface. Tectonic waves create a constant vibrations on the surface of the Earth, which can have different frequencies and time intervals. These vibrations are what we call earthquakes. Earthquakes and how they interact with buildings. The rolling waves of seismic energy that travel along the surface of the Earth's crust cause lateral accelerations. The lateral accelerations cause buildings to deform and then fail. The Mexico 2017 7.1 magnitude earthquake caused the deaths of approximately 230 people, making the earthquake safe structures. Geotechnical earthquake engineers have specific methods and standards for buildings in high seismically active areas to safeguard them from collapsing and killing inhabitants. Ensuring that a structure of a building is earthquake resistant is key to minimizing casualties. Methods and design of construction. The survivability of buildings can be increased if there are better construction methods used, better choice of materials, i.e. less masonry and lighter roofs, to prevent people from being crushed from collapsed buildings. The natural frequency of buildings isn't in the range of the frequency of the earthquake. Buildings with 5 to 16 stories saw a greater failure rate as their natural frequency was in the range of the earthquake's frequencies. Specific earthquake impact reduction methods can also be used, and these include the use of shear walls withstanding lateral forces and seismic loading, the additional use of isolation shock absorbers, or cross-bracing frameworks, which can transfer movement away towards the foundations. Slope stability. In the second week of the challenge, we learned about the resistances of inclined surfaces and their failures by sliding or collapsing. This is key as it can minimize damage caused by earthquakes from landslides. If the Earth's crust vibrates and disrupts the force of friction holding sediments in place on an incline, this can cause a landslide. The main factors of a landslide include soils losing strength from weather like rain and therefore collapsing easily in an earthquake, or shear stresses and lateral accelerations being too great and causing slopes to collapse. A solution is to build various types of walls, including gravity walls, piling walls, anchored walls, or cantilever walls. Stadium. In the 2017 earthquake, the stadium suffered a large crack on one wall. But how can we improve its evacuation plan? First, we had to consider the width and number of exits to ensure the best distribution of the crowds and zone safe areas reachable within acceptable evacuation time. If earthquakes occurred, it's important to have an evacuation route as it can provide safety. We have to ensure that paths are unobstructed and ensure that multiple different modes of transportation speeds don't use the same routes, i.e. pedestrians and cars. Factors to consider include the number of people, the number of exits, door width, safety areas, the reaction times, and the distance. To improve the evacuation, we decided there should be more exits, a reduction in some seating, for more width for people on footpaths and stairs, the implementation of a tannoy and speaker system in case signs or displays are illegible, and appropriate, clear, unobtrusive signage.